Hi, everyone. We're going to talk about Blender. I'm not very fast in English, so bear with me when I stop. Help me a little bit with the words that I can't remember. Um, I understand that you already had a class about Rhino and some other 3D tools. Blender is different from all that tools in several ways. The most important from my point of view is that Blender is an open source tool. So this has a lot of meanings. For some people are very important and for others it's just a minimal difference. But I'm going to talk a little bit about that in the introduction. Blender is a tool that's developed by a community of people, leaded by a foundation in Holland, in Amsterdam. So the motivations of the developers, the programming people, are different from the ones that do Rhino, for example, or AutoCAD, or another kind of tools for 3D modeling. So the developing paths of Blender are several and different. So there are a lot of different tools inside Blender. Blender covers from 3D modeling to 3D game making to composition of videos, edition, sculpting like ZBrush, maybe someone knows it. There's a lot of tools inside one program. So I'm going to try to mention all of them and try to make a brief introduction on how to use the user interface. And maybe we can get in this a couple of hours to start modeling meshes. Okay? But if you want to get inside Blender, you need to use it much more time than this. This is going to be only a little introduction. So Blender is free. You can download it from the webpage. It's blender.org. In the About page, there's a lot of information about the principles of the foundation and why they are doing this and which are the ways they want to take the software. So maybe you want to review it later. Blender, as I said already, has a lot of different features. It has a renderer, a photorealistic renderer. It has modeling tools, obviously materials for the render, but in a node interface based for the material, for post-production, and for textures like this. We later want to talk more about this. It has rigging tools for making animations. It has a great focus on building animations and special effects for movies. So there's a lot of tools that maybe we will not cover here, but there has some uses in 3D printing and in 3D modeling for fabrication. The animation toolset is very, very big. Sculpting is a feature that is nice to have in a 3D package because you can start modeling a rough model and after that have some details with the sculpting that gives you more freedom in the type of modeling you do. It has obviously unwrapping tools for texturing the models, so you can unwrap the geometry and after that put the 2D maps inside the model. It has a compositor. A compositor is like, well, I don't know if everyone knows about that concept, but it's like a Photoshop on steroids on time. You have layers and filters, etc., but you can change it in time. It has a simulator for water, for smoke, fire, clouds, particles, a lot of things like that. It has a game engine inside it. It's nice that it has a game engine, for example, for making interactive installations. It's easy to connect Blender with Arduino, for example, and have an accelerometer outside that gets inside the Blender world. it's easy to make a lot of interactive things between a 3D world and an exterior electronics. Also, it has camera tracking. It's like you can reconstruct the position of a camera after the footage has been filmed. And with that, you can put 3D objects inside the film without making, how do you call it in English, motion capture, without motion capture on this trackers. It has a system for developing extensions. Inside of that, you can develop scripts with Python. It has its own set of API instructions, so you can interact with all things in Blender through Python. That's also very interesting because you can link a lot of applications that you build, for example, for controlling machines from inside Blender, etc. It has video editing features, well, these file formats, and a flexible interface. We will now start speaking about the interface. It's flexible, maybe too much flexible for the beginners because it is a little bit confusing. Okay? So I hope everyone has installed Blender in your computers. If you did, when you fire it up, you get an interface like this one. Okay? In the top, we have a bar with the normal things of a bar, the menu, file, etc., render, view, window. And after that, we have a menu that we can select different kinds of interfaces. The 3D view, animation, compositing, etc. So for explaining this, I'm going to talk a little bit about the window system inside Blender. Blender has his own windows inside. The paradigm that they use for developing them is windows that don't overlap, that don't block themselves. So if you make a new window like this, you have two, but if you displace one for one side, the other one retracts, okay? Then you can also put windows horizontally, vertically, the way you want, okay? And keep doing a lot of different things. In this menu, the top one, there are presets for different kinds of tasks in Blender. The first one gives you a 3D view in the full screen. This is great when you're when you want just to concentrate on the 3D modeling. This is the nicest one. Then you have animation. Later I'm going to explain a little bit about the type of windows. Compositing is for making video compositing. Also, when you output a render from a 3D scene, you can modify it later in like a 2D image with some filters, with changing the lighting, etc. in these windows. The default one, right now I have it a little bit messed up. Another one for developing games that has a screen under that you can program the logic of the game inside it. Motion tracking, you can load videos and make the tracking of some points. Sculpting, scripting. This one is you have a Python console in down, and you have a text editor in the top, so you can script with the 3D view. UV editing and unwrapping is for texture works, and at the end the video editing feature. Okay, this is a non-linear video editor like Final Cut or that kind of stuff, Premiere. Okay, so we're going to start with the default view. You can design your own views, and if you see here, you have a little cross, and you can put a new one and change it as you like and save it in your default file. So every time you open Blender, you have your custom interface. On the side of the interface selecting tool, you have another one that says scene. The scene in Blender is a complex concept because it has everything inside it. When you save a Blender file, you are not just saving the geometry, you're also saving the settings of the interface, you're also saving textures, programs, text files, everything that you did inside it is saved in the Blender file. And even you can save different scenes in one file. For example, if I make a new one, I can have two different scenes that can interact between them, but they are separate in all the data management way. Until now, anyone has any question about that?
Quick question. So you said there's an API with Python. Does it mean that we have an Arduino, we can connect the Arduino with Blender?
Connect
an Arduino with Blender?
I don't know. Arduino, yeah. Yeah, of course, I said about it. You can make a Python script that gets data, for example, for the serial port from Arduino, and with that make changes in real time to Blender, or like a tool that you can, for example, you can develop a 3D scanner with Arduino and feed the data to Blender through Python. Yeah. You can modify the geometry. You can modify the game engine, for example. You can get an accelerometer and get the data to a game and make a kind of joystick with an accelerometer, etc. You have access to all the modifiers inside Blender and the geometry with Python. What else? Well, more or less that's the interface. Now we're gonna start seeing each window. There are several types of windows. If you notice the biggest one here in the default screen is a 3D view. Later we're going to talk about how to navigate the 3D view. Maybe all of you know how to, but it's a little bit different from Autodesk tools and other 3D tools in the way that it works. But every window in Blender has a bar, can be at top or at bottom, with the menus that affect that window, not the whole program, but that window. And some menus and sliders to change some things. In the 3D one, we have one that is important, is the mode tool. Here you can select the edit mode that you're going to use for editing your geometry. Later, when we start doing some modeling exercises, you will understand what those means. You can change also the pivot point of your geometry, the manipulator settings. These 20 little buttons that you see here are a layer management system that Blender has. It's very simple, but at first time it looks complex, but after some time of using it, it's very simple. You can change layers and have objects in different layers, and you can visualize at the same time different layers, or only one, or two, or three, etc. It has a snap tool, it has the render button, etc. And this window, if you click, well, I'm going to make a parenthesis, you say in English, about the normal way of using Blender is with one hand, the left hand if you use your right one, in the keyboard, and the other one in the mouse. It is designed for that kind of work. It is very heavily, it uses very heavily the key shortcut. So if you don't learn the shortcuts, you're going to be a lot slower than if you do. Everything is designed so you remember the keys. For example, if you want to move this cube 10 units to the right, you just have to click grab X 10, and you have moved it already 10, no? Without touching your mouse. This kind of movements applies to all the Blender interface. So it's easy and important to learn those tools. You can do the same as in other 3D programs, grabbing the X arrow and taking your cube here, and you can check how much units you have moved here and etc. But it's a lot faster than if you just do grab X and give the units you want to move. X is X-axis. Tab? No, G from grab. Later we're going to talk about the shortcuts, and I'm going to give you there is a lot of sheets in the internet that you can learn the primary shortcuts. But what I'm trying to say is that it's very important to try to keep one hand in the keyboard and the other in the mouse, and not using only the mouse, because you will be a lot slower working in Blender. Okay, so this is the 3D editor. It has, if you click the N key, it will slide another window on the right. That is the property window. Right there you can edit by numbers and sliders and clicks and menus all the properties of your 3D scene. And if you click T, you get another one in the right that gives you different set of tools. Okay, here you have, for example, a tab that's called Tools that gives you to move, rotate, etc. buttons. Then Create gives you all the primitive creation buttons and buttons for creating curves and lamps and etc. Relations to change the relations between objects, like if you have a parent object and a child object and they are grouped together, etc. The animation tools, the physics tools, and one thing that is a funny tool in Blender is something called the grease pencil. In all Blender windows, or almost all, you have a grease pencil. It's like the concept of a crayon that you can paint over the glass, over the screen. But you use it inside the Blender interface, and you can annotate, make animations, make everything with just that tool. It helps a lot for explaining things and doing like secondary work. Then in the tool window, in the bottom, we have a window that tells the properties about the last action you did. For example, if I move this cube in the Z-axis, I can see here how much I move it, in which axis, and which orientation I use, etc. And I can change my last action here. I can change how much I move the cube, in which axis, etc. Okay? So the 3D view, that's, I think, the most important part of Blender, has on the right the property window, on the left the tool window, and if you do it like this, you work only with the 3D view and the shortcuts. Okay, that's the fastest way to work in Blender. Also, you have, if you press the space bar over that window, you have a search tool for searching any kind of commands inside Blender. So if you want to move, you just have to start typing what you want to do and select the command, no? What else? Well, to maximize one window, there are a lot of shortcuts. You can do it, for example, with Control and the up arrow. So every window that your mouse is over, if you click that combination, will maximize himself. Okay? Then, on the right, in the default view, there is an important window. It's called, I don't remember which name they give to that window, Properties Editor. This one is the main window for editing the properties of all the objects in the other windows. Here we have on the top a series of buttons that defines what's on the bottom. The first one is the render properties, and you have a lot of menus for changing the render settings. post-processing, the resolution, what render engine you're going to use, etc. The next one is render layers. It's about which layers you want to render and which passes you want to give them. Then you have the scene. We are going to talk about each of one of these in more detail. The world tab that gives you the properties of all the world, the sky, the gravity, etc. The geometry one that changes depending on which object you have selected and gives you the properties of that object, the location, the rotation, etc. The link and constraints. The modifier. The modifier is a concept that you can add modifiers to an object or an entity that modifies the origin of that object without changing everything. So you can go back in time and change the modifiers or remove one and use only the last one, etc. It's like a fila, a line of several modifiers. Then you have one about the mesh and the vertex and the parts of the mesh. Later we're going to talk about it. Materials and textures. Particles. And simulations, no? Cloth, etc. Fire. In this is one of the most important windows because all the time you select an object and change something here, and go back to the 3D view and back to here, etc. In the top of the right side, we have another different window that's called the outliner, that gives you like a menu view of all the things that are inside your Blender scene. You have the objects, the cameras, the lamps, the properties of the render, the properties of the world, etc., etc. You can turn an object on or off here, select it or not, that object being able to appear in the render or not, etc. So this is a good window when you have a complex scene. If you have like 200 objects and you can search by name and change properties by name, not also trying to find it in the 3D view and selecting them there, okay? And in the bottom, because Blender is very oriented to animation, you have a timeline. The timeline that makes the possibility to make animations, okay? What else? Well, mostly that's the default interface. Every window you can change its size. You can change which window it is. If you see in the menu of each window, the first button is a button to select the type of window. So this 3D window, I can change it to an outliner, for example, and have another outliner here. Or I can change it for a timeline or whatever you want, no? A node editor, etc. Okay? So you can customize the interface in whichever way you like. Well, everyone that I talk about when they compare Rhino or AutoCAD or that kind of programs with Blender says, but Blender is not enough, it doesn't have the precision, the sufficient precision to make engineering works. I don't agree. I agree that the tools are different and you have to approach to that tools in a different way. But it does have the sufficient precision to do engineering works if you change your paradigm about how to model inside the application, okay? So I think you don't have to compare it with Rhino, but you have to understand that it's different approach you have to use in each program for getting the same result. One of the things that is important to learn in Blender is that Blender manages a lot of types of geometries. You can work with meshes, you can work with NURBS, you can work with metaballs, you can work with different kinds of geometries, and it's not focused only on one of them. So you can combine them and change between one or two. And you have to select which kind of geometry is better for the kind of object you want to model, okay? The strongest part of Blender is the mesh modeling part. It's the best developed, and it has more years than the other ones. NURBS, for example, if you compare it with Rhino, Blender NURBS are not very good. Okay, they are very limited in the kind of thing you can do. But in the mesh section, Blender is a lot better than most of those programs. I was formed in 3D Max, in 3D Studio, and when I changed to Blender, you have a lot more freedom to model here than back there. No? But it's true that there are some tools in commercial programs that you don't have here. Okay. What else? Well, mostly that's the interface. Anyone has any question about the interface? I'm sorry that I go like this. My problem is English. I don't think in English, so I have to translate when I talk, so I'm slow.
One question.
Yeah.
You mentioned there's different types of geometry, we'll say Rhino. Is it possible to model something in Rhino and then import it into Blender?
Yeah. Yeah. You can change between types of geometry every time, but there are some steps that are more difficult than other ones. For example, if you model a mesh and you want to convert it to NURBS, that's difficult. It depends on the kind of mesh you have, you can't do it. Okay? For that, we have to understand how every type of geometry works. I'm going to start talking about that. And maybe you already have an idea of how NURBS works, no? Because you already have a Rhino class. The mesh is based in a completely different approach about geometry. So not always is easy to change from one to another. And if you want to change, you have to keep it in mind when you start modeling, because if you don't do it, maybe you go to a callejón, a place where you can't come back.
Yeah.
Okay. So in NURBS, everything is based on curves, mathematically defined, and in mesh is based on vertex that are points in space that you only define by their location in space, by edge that are lines that join 2 points, and by faces. The faces are defined by 3 points in space or 3 edges in space. For example, this cube, if you put it like this, you can see these are the vertex of this cube. Okay? So I can select and change each vertex or each edge. If I select 2 vertex, I have 1 edge selected and I can change that. If I rotate this, I rotate the edge. Okay? And there's faces like this. Okay? Faces are a little bit more complex. The basic face is defined by 3 edges, and that's the more simple face you can have. But joining different faces, you can see quads and more complex faces that has different good things and bad things when you model. The most normal way of seeing faces is like a quad, like this. But in the end, at the end, mathematically, they are defined by 2 triangles. Okay? Sí. Yep.
I always thought that quads are the best type of faces for modeling.
It depends on the type of model you do. That's one of the myths about mesh modeling, because when you want to model something that is organic, you always use a modifier, a way to smoothen faces. That's called subdivision modeling. Okay, that subdivides the faces and makes them smooth. And if you smooth triangles, is the artifacts you get when you smooth it are not, they are very nasty. And instead, when you use smooth quads, you get very fluent surfaces. So if you are modeling a face, for example, that's one of the most common examples, you want to keep quads all your faces. You don't want faces with 5 sides, you don't want faces with 3 sides, but that's a detail about one type of modeling. If you are modeling buildings, it doesn't matter if you have 3 quads or pentagons or whatever, okay? So it depends on the type of modeling. If you are modeling for 3D printing, when you export as a STL, you always get 3 side faces. And it doesn't affect the model because the program subdivides the curve or whatever in some, the faces you said to him about resolution. No? If you have some curve, at the end the curve will be subdivided in several triangles. The important thing there is when you export your object, you have to tell the program how much precision you want in your curve, okay? One of the common problems for beginners is we ask for too much precision because we want the curve to see perfect, to be defined perfect, but when we import that mesh in Cura or in some slicer software, Cura crashes because it's too much detail for an STL file, okay? So we have to understand how each type of geometry works and what are the better practices in each kind of geometry. Okay, so I think no. Quads are good for modeling faces and organic models, but not every time. Okay?
You apply a texture as well.
But the textures apply as well over triangles without a problem if you do a well unwrap of the model. That's another kind of art. Yeah. Unwrapping in the right way is very complex. Okay, so in Blender, down here you have different modes of editing your object. You have object mode. In that mode, you change all the objects you have in your scene. For example, if I have 2 cubes and I want to move one, I have to be in object mode because if I am in edit mode, that's the second option here, I just work in this inside the elements of that object. Okay? The one object is an entity that has inside a series of vertex, edge, and faces that are linked to one point that's the center of the object. So if I move that point, I take with me all the parts of that object. And in edit mode, I can edit all the inside parts of each object. So when I have a complex scene, it's convenient to have the geometry divided in several objects, so we can tweak and modify separately each one of them. And also it's normal to start modeling with some primitive objects, and we add a new object, modify it, and add another one, modify it, etc. First off, before starting the modeling stuff, I will give a brief introduction on how to navigate the 3D view, unless you feel comfortable moving inside. No, you want a brief explanation? Blender doesn't have a unit like a kilometer or a meter. You can set it, but in fact they call it like Blender units. So there are abstract units, and you can go as big as you like or as small as you like. Okay? For going small, there's a limit, but for going big, there isn't. It starts with when you add a new object, it starts with a dimension of 1 or 2 for each object, depending on which object you add. But you can scale an object, and you can move it around the 3D view, and you have to reposition the 3D view, like in any other 3D program, around that object. We have, it's normal to use Blender with the keyboard, like I said before, and it's important to have the numpad. Well, not that important, but it's useful. It's a problem in laptops because you don't have it. Because with the numpad, we can change views, if you saw right there, very easily. We can go to the top view, the front view, the side view, etc., with one key. Okay, so we get used to work with only one 3D view, not with four. Like we have top, the side. We change very easily here. So if I want to see this cube on the side, I do it like this, and I modify it here. And after that, I can go to the top view and see the other, and etc. Okay? So in the numpad, you have a way to navigate the 3D view that's very, very easily. You have 7, 1, and 3 are top, side, and front view. In Blender, almost every shortcut has a modifier with Control, Shift, or Alt. So for example, if you do Control 1, instead of getting the right side view, you get the left side view, okay, the opposite one. And if you click 7, you get the top, Control 7, you get the bottom, okay? Then with the key 5, you can change from a perspective view, like this, or an isometric view. I don't know if that's the right word in English, but the one that doesn't have a deformation. The things are not smaller if they are farther away.
Asymmetric?
Asymmetric? Isometric, okay. Isometric, yeah. And what else? Well, 2, 4, 6, and 8 rotates the view in an horizontal way or vertical way, in steps. 0 gets your camera view. The point centers the selected object because it's easy to get lost in the 3D view. So if you select an object here in the outliner and you hit the dot, immediately you center your view on that object, the full view. Well, the plus and the minus sign obviously zoom in and out. What else? That's mostly the keyboard keys to navigate the 3D view. And the mouse is important to navigate the 3D view. With you can do everything with the middle buttons. Okay? If you have a normal mouse, an external mouse like this is easier than if you have a mouse pad. With a mouse pad, it's very complex to navigate the 3D view. So I recommend you have this one, even that you have a laptop. With the middle button, if you scroll in and out, you have a zoom. If you press and move, you rotate your view. If you do it with shift, you can pan your view, you can move it. So with those 3 ways of move, you can go to every place in the 3D view. This class is going to be a little bit short to go into more detail, but it's a good practice to try to navigate and go inside a cube and see it by one side and by the other, etc. There, you get some time to get used to how to move the 3D view. Okay, so about modeling meshes inside Blender. There are a lot of tools for modeling meshes, but we're going to start with the simpler ones, and I'm going to show some modifiers and some Boolean operations and things that I think are a good way to start modeling stuff that you can cut, you can print, or you can do something with it in the machines around us. There's also a lot of tools for organic modeling, but I'm going to keep them for a later part. Okay. Here in the menu, you have a lot of things. I'm not used to use those because everything you have it in your left hand. For example, if you click Shift A from Add, you have a menu with all the objects you can add inside Blender. We start with mesh objects, curve objects, surfaces. The surfaces are NURBS, like the ones you use in Rhino. The curves are Bezier curves and NURBS curves, but mostly two-dimensional ones. It's like Inkscape or Illustrator, etc. After that, you have Shift A. Metaballs. Metaballs are a way, like, I don't know, but like 30 or 40 years ago, technique for modeling that you make spheres, and if they touch, they make a connection between them. You put a lot of spheres and you make a bigger model. You can add some text and change fonts, etc., and give them volume. You can add armatures that are for rigging characters or rigging objects for making animations. There's also some interesting part of the rigging objects for machine design, because you can simulate robot movements, etc., with a properly designed rig. Lattice that are like grids that has a lot of uses. An empty object, that's a concept, a strange concept that I don't know any other program that uses empty objects, but in Blender they are very useful because it's an object that doesn't have anything inside it, only the center point. And you can use it as a reference for rotating other objects against him, for scaling other objects, having this one as a reference. Later we're going to use it in a... Yeah? Okay. Yeah, for a lot of work.
What tool is this one?
What?
Which tool are you talking about?
Which object? The empty object.
Empty. Okay.
Yeah. Also, Blender has, now that we are talking about empty objects, I remember it has a 3D cursor. That's a strange concept also. This is the little round thing, white and red. The most normal thing in a beginner of Blender is want to select an object and start clicking, and the object doesn't get selected, because in Blender we select with the right object, not with the left one. It's different from all the other programs. But when you click with the left object button, you can see that you're moving that little circle. That little circle is just a cursor that you use as a reference. For example, if I want to rotate this object, I click R, rotate, and start rotating in the view that I'm aligned. If I click Z-axis, I start rotating in the Z-axis, if I click the CK. But if I click the point, before rotating, I'm using the 3D cursor as my center point. So the same operation of rotating now is very different from the other one. Okay? So the 3D cursor is very useful. For example, if I want to align some object, I can put the 3D cursor in that object and use it as a reference to rotate another object or move it to the same place. Or it's like an aid for making changes in positions, and scaling and rotating. I get lost in what I was talking about. Okay, add objects. Okay, so in the beginning we have a cube. If we click the tab key or we change to edit mode here, we can edit the elements of the cube. As I told you before, we have vertex that are represented by little points, edge that are lines that gets those points joined. If you select 2 points, you select the edge, but if you change with Control Tab the way you edit the object, you can select vertex mode, edge mode, or face mode, so you can change only those elements of the geometry. If I select edge mode, I can change directly all the edges. Okay, I can select this edge and move it. If I am in vertex mode, I can move the vertex itself. Okay? If I select faces mode, I can move all the face around. One way of start modeling, a simple way, is to extrude things like you do in other 3D programs, but if you select one face and click the E, you can start modeling like this. Okay, this is a simple way, but it's very nice to start like this because you can do complex shapes in a matter of seconds, and later you can modify these shapes with modifiers or other things. You don't have to make a boolean with 9 cubes to get that shape. You can extrude, and keep extruding. Yeah.
Where do you get the face selection?
Control tab. I'm sorry that I won't get you reference by menus. I prefer to do it by keys because if you learn the keys, you're going to be a lot faster. And the menus, you can explore it by yourself and find where they are. Okay. The tab key is a normal key in Blender. You use it a lot for changing modes or selecting different kind of geometry. Or in different windows, it has an important role every time. Okay, so you can, to each element of an object, you can do the same things that you can do to an object. You can translate or change the position, you can rotate, or you can scale. Obviously, the only thing you can't do in a vertex is scale it because it's one point in space and you can't scale a point, but that's the only limitation. The other things you can do to everyone. Okay? The 3 keys that are that you use more are G for translating an object. It's a strange thing that they call it grab an object and move it. So the G is for grab. Then S for scale an object. R for rotate an object. You can do the same with the buttons you have on the left, and you can do the same with vertices, faces, etc., etc. Okay? Now, there's some difference between the normal window or Macintosh programs and Blender in the way that we interact with them. In Blender, when you click G for grabbing, without clicking any button or anything, you can start moving your mouse and your object will move. And if you click the mouse, you are giving a confirmation that you want that position. But if you click the right mouse, you are canceling the movement. Okay? So it's not like a click and grab paradigm. It's more like, I want to do this, I do it, and I confirm or I cancel. Okay? That's mostly the way of doing things. I want to rotate, so I click R, start rotating, and when I end, I click my button. And in the middle time, when I click rotate, I can click other things. I can click dimension. I want to rotate only 90 degrees, so I click 9 and 0. And there you go. And you can cancel with the right button or confirm. Or if I want to grab an object, but only in Z-axis. So I click the Z-axis, and when I move with my mouse, it's constrained to that axis. Okay, I will not go for all the the shortcuts, because they are a lot, but you more or less get the idea of this. So there's a command, modifiers of the command after that, and confirm or cancel the action. This may seem complex, but once you get used to that, you're very, very fast modeling. Okay, a lot faster than have to go here, click, and grab, and click another button, and because your mouse will stay all the time inside the 3D view. You don't have to go to a menu and click and go back and move, etc. There's a manipulator, like the one you see here, that's copied from other 3D programs. The first versions of Blender didn't have this, but a lot of people complain about not understanding the way Blender works, so they put it inside. But for people like me, you can turn it off here, and you can just use your keys. If you want to use that, you can do it as any other 3D program. If you get the X arrow, you move on the X axis, etc. And the manipulator can have tools for rotating, for scaling, or for moving, as the keys that I mentioned before. So those are the things you can do to an object, or to a vertex, an edge, or a face. Also, the other normal thing is to extrude. I have already said it. You can do it to a face, you can do it to an edge also, or you can do it to a vertex. If you extrude a vertex, you get an edge. If you extrude an edge, you get a face. And if you extrude a face, you get a volume. Okay? So everything is based on these three elements and how they relate to each other. We can change a lot of things about those. For example, if I want to move this one, but I want to affect the others, I have a way of telling Blender that I want a proportional editing. So when I grab that vertex, this circle makes me affect all the other vertex. No? So I have a smooth way of modifying my mesh. There are a lot of tools like that one that may seem complex right now, but when you're into editing meshes, it seems like very complex because I have like 800 points, but you can edit it by groups or by projecting other things, not one by one. You don't have to change every point of the eye of the model to change the eye. You can select a lot of points. You can use this type of tools like proportional editing, etc. Okay, that's the basic way of editing a mesh, changing the elements inside an object. But you also can edit a mesh, mixing different meshes, replicating the same mesh, changing properties of that mesh with the modifiers I talked before. Okay? So, for example, if I add a cube and I duplicate that cube. For duplicating a cube, you click Shift-D and I put it here. This is a normal operation in any CAD program, a Boolean operation. So I go to my property editor window and the button that has a wrench key has the modifiers. There are a lot of modifiers. They're separated by 4 groups. The first one is modify, the second is generate, to generate geometry, the forming modifiers, and simulation modifiers. Okay, I'm just going to talk about a couple of them. There are a lot of tutorials about each modifier. At the end of the class, I will point you at some resources pages so you can keep digging yourself. If I want to do a Boolean operation, here I have the modifier. I select it and he plays the first one. If I keep adding other modifiers, it will appear at the end of the line and I can move one to the top or to the bottom and it will keep upping the modifiers to the geometry in order. First this, and the result of that it's going to be added to the second, to the third, etc. Okay? For example, I have a Boolean when I have this cube selected. And I have to select which is the other object that is going to participate in the operation. So I select the other object, the other cube, and which kind of Boolean I want to. If I do put union, I then have a mesh that's with the two cubes united together. Intersection just give me the point where the two cubes cross. I have to hide the other one to see the intersection, is this. And difference will subtract one cube to the other. This is a normal thing in 3D programs, and you can do it with meshes here. The thing is that if I edit my cube and go again to edit, I will edit the first mesh, not the modified mesh, okay? So if here I move one vertex, and after that I go out, I will change the original cube, and the Boolean operation is going to be applied after that modification I did. Okay? That's easy to understand. And I can keep adding different modifiers over that. For example, an array modifier. I can make several copies of my cube. This is a good place to make an example of an empty object. If I add an empty object and I tell this, I want to make an array around that object, if I rotate my empty, my array will copy that rotation, the rotation of the empty object, okay? If I scale my empty object, then the array will scale in the same proportion. So each copy will be a little bigger, a little smaller, a little more rotated or less rotated. And everything, if I turn my modifiers off, is back to the beginning of this. No? And I don't lose any of my changes. They're all there, and I can rearrange them, so make the Boolean after the array or before the array, etc., etc. Okay? It's clear or not? I see a lot of questions in your faces. The modifiers had a lot of settings. Each one has different settings, but most of them has a camera button and an eye button. The eye button is if you want to see it in your view or not, the effect that modifier is having over the geometry. And the camera button is if you want to see that the consequences of the modifier in the render view. Okay? So you can turn off or turn on every modifier in different parts of the result. And you can stack as many modifiers as you like. Also, you can apply the modifier. If you like this and you want to edit the geometry only of this cube, not the other, then you can say, well, the array is right as I want it, so apply the array. Okay? And after that, I can modify only that cube without modifying the rest of the cubes. Okay? If I do that before applying the modifier, I will affect all the cubes because all of them came from the same one. Okay? Questions? No?
If you've been playing around with Rhino, you know, it's just hard to get used to the different movements and skills. Is there a simple way of doing this, or you just have to get in?
I think there's no easy way solve that. You just have to decide which one you like more and drop the other one, I think, if you want to go deep in a 3D software. Because being a master in all the 3D softwares will keep all your time off and you don't learn how to use the CNC machines. So, yeah, I think these are really big programs, both of them. Blender is is biggest than the other. So you have to learn just what you need for this course, and after that you start going deep and deep if you like.
It seems a lot more flexible than Rhino in certain ways.
I think that, yeah, but it's like a discussion between fans of different football teams, so it's not easy to get a result on that discussion. Yeah. I think one of the important things of Blender is more the origin of the software, more than the software only as a tool. But that's my speech.
You mean the open source?
The open source thing and the community related thing, you can get support from Blender from anyone. If you go to the Blender Artists Forum, you get help from everyone at any time of the day or of the night, because there are users in every place of the world that work in Blender like a fan thing. No? Because everyone that works in Blender loves Blender. It's not because a company sell it to me and I use it for my job. It's because I am Blender. I use Blender because I make a script and give it to the other people, and everyone give me an applause. And it's like making community, you know? And that makes software different. But it depends on everyone and the purpose you have on using that software. Okay, so I would like someone to give me one example of a thing that you would like to do inside a program like this. What thing anybody?
I was interested in when you mentioned the scan, 3D scan, something to
3D scan something to use it in Blender. The problem here is that I don't have a 3D scan right now, but the thing is, when you 3D scan, a 3D scanner works like getting 3D points of something, of an object. There are several types of 3D scans, but most of them use a laser and converting that silhouette that the laser does over an object in 3D points, triangulating the position. Other ones, like Kinect, use some infrared cameras to measure the distance of a point in between the camera and the pointer. So all of them give you a series of points. It's called a cloud point, you know, because there are a lot of vertex, and sometimes the software that you use for 3D scanning gives you also faces that joins those points. Sometimes it doesn't. It just gives you the points. You know? And most of the times there are like several thousand points, or sometimes millions of points, you know, depending on the complexity of the object you scanned. And using that kind of meshes in a program like Rhino is very, very difficult. It often crashes the program, you know, because it is not designed to manage that type of geometry. In Blender it's very easy because it can handle very big meshes, but it depends on what you want to do to that mesh. There are several operations that I can mostly teach you without a 3D scan about cleaning the scan, for example. There are some noise in the 3D scans, some things you want to remove, some things you want to polish, etc. One tool that I found with my experience that's very useful for that is the Sculpt tool. I will now give a brief explanation of that, because you can do it not point by point, but like with a brush. You can smooth this area and remove the little holes, or you can grab all this and move it through here, or scale only this far, something like that. You know, it's more like an analog way of editing a mesh, in not a digital way. I will do an example of the sculpting tool. Down here, I have only showed until now the object mode and the edit mode, right? Those two help you to change the objects and change the vertex and edge, etc. But there's also, I'm going to add a sphere. Before I start sculpting, I would like to show you one more modifier that's very common. It's called subdivision surface. It's the one that smooths geometry. It's very common to make a rough geometry about some object, and after that, subdividing it and smoothing it at the same time. So when you add this modifier, you can change the level of detail. If you see my sphere, and I change here the level, you can see this is the starting point, and each time I put some other level, it subdivides each face in smaller faces. And the good thing about this is that you can always come back to this, and you have a simple mesh that's going to be presented as a complex mesh, but it doesn't have to be that complex for example, for a 3D printing machine. If you want to go back to a simple face, you can go to a simpler mesh. And for example, for sculpting is good because you can get a simple sphere and get a lot of detail from it. So if I apply that modifier to my sphere, I have a lot of faces, vertex, like any 3D scan I can get. And here, if I go to sculpt mode, I can do changes to my sphere in a more natural way. No? I will show you some tricks about this. If you go to the Properties tab here, go to the bottom, you can change the way Blender shows you the model. And for sculpting, it's very common to put a shading that gives you more idea of what you are doing. And con el espacio. With the space bar, I told it before, you can get a menu for searching anything. So right now I don't remember what's the shortcut for smoothing a mesh. So I press the space bar and I type smooth, and here it is, object, shape, smooth. So if I want it back to flat, I just have to take flat, and that's what I get. Which one? Ah, the right one. That's one. Oh, sorry. N. The N key. Or if you don't remember the N key, at the right top corner, there's a little cross in a little tab that if you click it, ta-da! Okay? So, here the sculpting tool, you don't have to count how much vertices you have, you don't have to go one by one. You have another type of tools for editing. You have tools that do blobs, that treat the mesh as if it is clay. You can make creases, flatten the shape, grab some part, etc. You can try any part of this. And one important thing here that Blender has is this one is called dynamic topology, that if you turn this on, the mesh will generate new geometry automatically when you make more detail to it. So if you want to go into detail and make some horns to a face, it will automatically make more faces, so you can put some detail inside those things. For example, Right now, you can see how much triangles I have there. But if I start giving some detail here, you can see that subdividing that in smaller triangles. If I go here, you can see that here are smaller faces than here. This is done by Blender automatically. I don't have to ask him to give more detail in the mesh. This is more like an artist tool, but for modifying cloud meshes or cloud point meshes, like the ones we get from 3D scans, is very, very practica, I don't know, useful. For example.
Sculptments, okay?
Sorry?
You're still talking about sculptments.
Oh, cool, yeah. Grab tool, for example. I can make my brush bigger, and I can grab wherever I want my shape. Okay? These kind of tools modify all the vertex I'm touching and all the faces I'm touching. And I can always smooth, get flattened shapes. It's more like a sculpting way of doing things. Not like, I also can go here and grab one vertex and move it, and still can sculpt over it. Okay? So, as you can see here, the sculpting tools have a lot of options. There are programs that only do sculpting, like ZBrush, that's very famous about it, only doing sculpting. And Blender, you can do sculpt over every mesh, every geometry you have inside. This is one of the tools that you can use for 3D scans. The other tool that's very common and it's very useful is the one that I used before, proportional editing. It makes a curve around the vertex you select, and it will affect the surrounding vertices in a proportional way. So if you grab one, you can define the area that is affected by your change. If I make that circle bigger, all that part of the mesh is going to change. If I make it smaller, only that part is going to change. Okay? And you can also select, if you want, which kind of curve you want for the decreasing of the effect, like a sphere one, etc., etc. Okay. Well, this is two of the tools that you can use in 3D scans. There's also some other tools for cleaning vertices. For example, it's very common that you have duplicated vertices that are in the same point in space, because the machine that scans some object will repeat a lot of points, or will put it so close that they are almost the same. In Blender, you can remove all the duplicated vertices. For example, if I grab all and duplicate them and move just a little bit, there are a lot that are going to be in the same place. And I have a mesh that's very, very messy. But if I select all of them and tell them to remove doubles, he will remove all the vertices that are on the same space. Okay? You can see here. He's removing the vertex that are closely between each other than the number I am modifying here. So this helps you a lot for cleaning meshes. That is a very difficult task when you get a messy mesh from a 3D scan. The other thing that's very useful is a modifier that's called decimate. Decimate is a modifier that simplifies a mesh based on a variable you give to him. Here you have the ratio, and that ratio will change the level of detail you can get. And you simplify your object by getting more or less geometry here, okay? There's also other tools that I'm not going to talk in this class, like mesh, how's it called? Mesh Lab. That's another open source tool that's very useful for cleaning meshes before you get it inside Blender. Maybe you can, we can talk about that in a later class. But mostly is this kind of tools you can use for polishing 3D scans. There's also a more complex and advanced tool that's called Retopo, that you do like a kind of grid, quadriculated plane, and you apply that modifier, and he copies the shape of the 3D scan, but only with the geometry it has originally. It's like if you let fall a soft grid over an object, and it will copy the shape. It's the same concept. So you get at the end an object with only the vertex that you have in your original grid, but copying the position that they adopt when they hit the base of the geometry. Okay? Maybe we can, everyone has Blender in his computer, maybe we can do a group exercise, because right now everyone has touch here and there, but I think, okay? So when you start Blender, you have something like this. Someone remembers how to change this to an edit mode? The tab key will give us access to vertex, edge, and face modifier. Let's make a human based on a cube. Let's extrude the arms, extrude the legs, and extrude the head. Then stretch the neck, stretch the elbows, stretch the different parts. For example, if I scale this in one axis and scale this, I can use this as a starting point. I can select one face and extrude it. There is a modifier that we can use in this kind of task that's called mirror, that copies your mesh in the other side. So if I do something in this side, I will get it in the other side. Okay? So for making humans, the symmetry is a good thing. So if we all start with a cube, shift, add a cube, and we apply a modifier that's called mirror, we enter edit mode and move our cube to one side. We have a starting point. Okay? Sí. ¿Podríamos hacer un descanso? Sí. Ya están.
No digo, pues nos damos información.
Vale. Tomemos un descanso. If you want to make a break. No, it's okay. Let's make a little break. Happy mirror?
Tots els programes, sí, amb SolidWorks es rota d'una manera, amb Rhino d'una altra, amb Blender d'una altra, amb SketchUp d'una altra.
Per exemple, aquí, a Interface, entens? Aquí ja et posa, veus? Seleccionar con tal, i després hi ha alguna pijada més com, per exemple, si estàs en Mac, si estàs en un portàtil, que no tens el touchpad, també hi ha el touchpad que està aquí, veus? Zoom to mouse position també és important per fer el zoom allà i està per aquí, no sé on està.
Clar, perquè anava dient shortcuts amb els números i això visual key.
No. ¿Qué pasa? Ya me ha contestado. Ah, mira, aquí, emulate, number pad.
Tengo que preguntarte dos cosas. Primero, no encuentro el código, no recuerdo dónde está, de la página de YouTube. Y segundo,
aquí.
¿Cómo se llama? El cable HDMI. Tenemos para enseñar.
Sí. Súper largo.
Ah, vale, perfecto.
Aquí. Tienes que abrir un evento que te lo he borrado.
Ya está abierto.
¿Dónde no encuentras? ¿Dónde no te acuerdas?
No encuentro el código de poner ahí en el OBI, no me acuerdo cómo se llama.
Aquí. No, aquí.
¿Es esto? Testing setting.
Sí. Pues aquí no, esto, no, porque después hay otro. I'm gonna explain some, I don't know if he explained it, but here maybe you have two nice things. One is the possibility to change the button what you wanna select the object. Normally it's the left one, and for default, Blender uses the right one. So if you are, I don't know, if you normally use the other one here, it's okay. And also, if you are using a laptop and you don't have the how it calls the numpad, if you click here, you're gonna emulate. So basically, you could use 1, 2, 3 to change. And the last one is this one, zoom to mouse position. Aquí, if you go to input, you have to go to file, user preference, and then input, and then here. Select width, and then the emulate number pad.
And select mouse, where is it?
Is here. Is this one? This is for the set to choose.
I mean the other one.
The zoom to mouse is here in interface. Here.
Ciao bello, come va tanto?
What's up? Are you streaming things? Mark is going to help you.
¿Qué puedo desenchufar aquí antes que me se apague el ordenador?
Espera. Antes de que apague.
Sí, va a pasar como en 60 segundos.
Pues vamos a desenchufar la Roland.
Vale.
No. Vale, ya he explicado todo lo que hemos hecho.
Sí, pero esto del código, ¿no?
Sí.
O sea, nosotros estamos aquí, él le ha llamado el...
Ok, soy... claro.
La llave, ¿cómo se llama?
La key.
La key.
Okay, so if he goes here... Vale, estos son todos los que ha hecho en su momento.
Ya, eso de la...
Ok.
Porque he intentado hacer directamente el live. Tiene que crear igualmente el...
No, pero yo lo haría así porque así lo podemos ya tener seteado y así se aguanta.
Vale.
Entonces, decimos que empieza a las 8, acaba a las 8:30.
Sí.
And then
Directamente con una...
class, public, whatever, okay.
Había puesto una...
Un stream, no, directo.
Ok.
Y ahora le decimos other, entonces control C, y venimos aquí, control V, aplicar, vídeo, versión máxima.
Pero no, quiero compartir solo una pantalla. No, porque voy a trabajar con las dos pantallas para que aquí me tenga el... Si no, tienes que abrir tu...
Claro, mira, esto lo controlas.
Mira, ahora colega con la Academia esta es la transmisión de YouTube directamente de esta. Pero si pueden ver solo No, lo que te quiero decir.
No, pero él no quiere
Pero-
hacer un mirror de los screens
Exacto.
cuando lo ponga en HDMI, sino que quiere poner
Pero
un parallel.
una pantalla extendida.
Pero esto hasta que no pongamos el HDMI, no, porque él está aún haciendo clase, no hemos acabado.
Ah, ¿y a qué hora empieza la clase?
A las 6, pero vamos con un repetitor. Delay.
Ok.
Ah, yo ahora le digo que acabe.
Vale, pero lo sabéis hacer esto, ¿no?
No lo probamos nunca. No lo probamos nunca. Eso que vamos. Que la transmisión de esto es directa. O sea, es directa a la página de la
Simplemente dice que estoy yendo.
Sí, pero eso depende de la transmisión. Hay dos páginas. Simplemente tienes que ponerle dos pantallas diferentes.
No, entonces no está directo a la pantalla, digamos, está directo al software, al ahora está grabando solo el software, no está grabando mi texto. Entonces tú te apagas la imagen, te vas al texto, hagamos una prueba. ¿El darle todo va? Ok, entonces. No, pero es. Esta es toda la pantalla.
No, este es solo lo del.
Lo que está grabando. Vale, entonces yo puedo tener otro Rhino, como decías tú, ¿no?
Si quiere abrir otro reino,
Vale.
debes tener dos reinos en la misma pantalla.
No, yo me pondré una pantalla extendida y tengo dos.
Vale. Vale, pero esto no pero aquí voy a hacer no. Déjame que le termine. Espera. Déjame que te ponga este primero.
Vale.
¿Vas mal de tiempo?
No, sí, para.
Ahora es que está en un
Momento delicado, por eso le sono pausa.
mi puoi inviare questo link?
Sì.
Così lo dici ai ragazzi. Ok, preparing. Pero no me deja, ¿por qué? Pero no si bla 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 bla. Ok, eso está transmitiendo. Se puede saber cómo. Espérate un momento. ¿Dónde estamos? Está conectado a la. Yo creo que se pierde. Mi funziona con la serie. Trata de cambiar.
How many of you are just to see the software? How would you use the only blender? How do you use I would download it. For Mac there is a trial version, but it's still not so solid. So a lot of plugins are not completely.
Yes. Yeah, I'm not sure if it's all too much.
But yeah,
Yeah, no, it's just the workshops. Yeah,
¿Funcionó? ¿No funciona? ¿Sí o no?
No, creo que tengo problema con el internet. Pero si puedes darle a pie transmisión otra vez, va perdiendo cada vez la conexión. Dice que falla.
Pero es que ahora no está, ¿no?
Ahí dice que está conectado.
Okay, let me like that he close the workshop and then. Okay, guys, we are out of time, so we have another workshop. Aldo is a kind of is a little bit in a hurry. So what we're gonna do is close this blended workshop 10 minutes, something like this. Yeah. Then we could do another one. I don't know, 2 days or whatever you want. So we could start the stage. But
I think the next one we can do it around practical subject, maybe modeling something for 3D printing or something like that. That I make more like a tutorial thing around you working on a specific task. I know that today has been a lot of information in one example, but after that I think you should try it a little bit, read a little bit, and start feeling comfortable in the Blender interface. So instead of modeling a human, if we only have 10 minutes, I will tell you a little bit about other parts of Blender, just that you can investigate yourself from now to the next session, okay? Maybe as an assignment, you can try to replicate a shape, a simple shape of a human, and we can check it in the next session. Okay, so what we didn't talk about yet is about the rendering system in Blender. You can see your mesh in different ways. Right now we're seeing it like solid objects, and in the menu down here we have different shading of our mesh. No? We can see it in wireframe, that sometimes is useful to see the back face of the model or the side views. And we have textured material, but we have a render of the view. We can see the render in the viewport and modify our object in render view, or we can render our view in an image and modify that image in a later step. In the menu that's up here, we can select which render engine we're going to use. Blender, as an open source project, accepts a lot of renders. Included with the package, you have the Blender internal render, that's an old render engine that renders simple shapes and simple shades. But it has also the cycles render, that if you have a graphic card that has its own processor, like an NVIDIA one, it's very, very fast, and it can do real-time renders with global illumination and a lot of the tricks that are used to do photorealistic renders. Okay, it's a very, very good render engine, and in fact, you can do a course of 6 months only about cycles engine and illumination and materials, etc. But it's interesting that you start testing and checking which kind of renders you can do, because it's a good way to present your project with the renders from Cycle Engine. So if you select here the Cycles render engine, and you go to the property editor tab, the first one, that's rendering settings, you have here the render button and some settings. when you click the render button, it will calculate the image, and after that, you can change and modify your image with the node editor. I'm just going to put this here so you can see what you can do. This is a different user interface from all the other windows, but it's very, very powerful to edit things like images. You have here your image. Every node represents a step of the processing of the image. You have one node that is the render itself, and you have nodes like, for example, a viewer node and composite node, and you can add with Shift A in the same way of in the 3D view filters. For example, if I want to make a blur of my render, I just put this here and change the values, and my image is blurred. No? And the nodes, you can put it around every process of the, not every process, to process every information you get from your 3D view, not only the image, but also the geometry, the normals, the light, etc., etc. So here you have a really complex tool, but a really powerful tool to process and give output to your geometry. Okay, this is a whole new animal, not apart from the 3D view, but it's very important and interesting to start learning it. So if you start practicing Blender, don't hesitate and make a render and try to put in some filters, change some stuff, etc. So mostly that's the Blender interface. You have a lot of windows that we don't have seen in this practice yet, but with the global idea that we have seen in this class, I think you can start experimenting and checking what things you have in there. And hopefully we can do the next workshop with some tasks, with some practical tasks that you can do, and I can help every one of you to start solving things. I would like you to think which kind of geometry or which kind of project you would like to do in Blender. We can talk about it and organize the next workshop around that. Maybe we can link it with the 3D printing practice, so we can model here, prepare the object, and finishing 3D printing it, and maybe having a render of the 3D printing object